we're up to module 2, which is here. All right. All right. So this is OS and file structures. And this is really the main thing. Understanding how files are stored is basically the central activity of forensic examiners, understanding how to recover files from storage devices. So we're going to talk about the Microsoft file systems, and so one thing to understand is that allocated space is files that are stored that are in use, which means they have a name and an owner and a timestamp. And when you delete a file, it's no longer in use, so it is still there. The contents of the file are still sitting there in the clusters on a magnetic hard drive, but they're no longer connected to a metadata entry that has a name and an owner and a timestamp. And those are called unallocated space. This is the fundamental reason why you can recover files. When you delete a file on a magnetic system, it does not actually erase the contents of the files. It merely removes the entry in the master file table saying those sectors are now available for future use. They're not erased until new files are stored on top of there. And that is not very common. So a typical Windows machine has got files left over for years, just sitting there, the contents of files. But you don't have an owner or a timestamp, so they're of limited value for criminal forensics, but they can be useful for other things. So a byte is 8 bits, and a sector is 512 bytes. You can only read and write a whole sector at a time, 512 bytes. The drive controller will not let you read or write any smaller amount, and typically you cluster it together to 4096 bytes for a cluster, and that's the smallest amount of space that you allocate to a file. Therefore, there's some wasted space when you store a file. There might be up to like 4,000 bytes that you're not using at the end of a cluster. So you've got, here you've got tracks, or what goes all the way around. Sectors are here, the smallest possible unit, 512 byte, and in fact you have clusters, which are typically 8 sectors, not to scale here, and that's what you actually use to allocate space to store the contents of files, is clusters. All right, so an 800 byte file would use 2 sectors and have file slack, unused bytes, in the last sector of the file. So you'll find file slack is fragments of a file and not even the start of a file, so usually it's useless. I mean, if you missed the first 512 bytes of a file and you get a few bytes towards the end, it might be part of a Word document or part of an image or something, but it's very unlikely to have anything useful unless you get really lucky and there's something in there like a password. It's not likely to really be worth much. What's far more useful is something that's been deleted, but the entire contents of the file are still sitting there. So you can find the file header and the file footer and reconstruct it and view the image or Word document or whatever it is. That's what you typically get from a forensic tool. Piecing together the fragments is not usually done because in practice it's not worth much. All right, so a platter is the circular hard disk here, and there's the read-write head and so on. All right, it doesn't really matter that much anymore because almost nobody's using these magnetic hard drives anymore. Everybody's using SSDs, and SSDs have background garbage collection and they do not retain deleted data to any significant extent, so none of this stuff matters. All right. The paging is important, though. If modern operating systems, you can open a file, open a program, and open another program, and open another program until they won't all fit in memory at once. And it will automatically take blocks of memory that should be in RAM and put them on the hard disk to free up the memory. So you can have more programs open than you actually have physical RAM for, and that's what the page file is for. Windows, very bizarrely, saves the contents of memory to the disk and takes stuff to the disk and puts it back in memory way before you filled up the RAM. In its own wisdom, it is very strange. You will find the strangest stuff in the page file and in RAM copied from the page files. I found things from like 2 years ago on a computer in there. It made no sense at all, but Windows is pretty opaque. All right, so it's pagefile.sys is the name of the file, and so it may contain information about open documents, open passwords, and so on. You can control the settings to some extent in Windows of the page file, but normally it's recommended by Windows tech support books to not change it. They say let Windows do what its default thing. You're not helping. Like turning it off, you might think you'd optimize performance if you don't have a lack of memory, but they say don't do that. Windows runs best leaving Windows do whatever bizarre stuff it does with the page file. And of course, we already talked last time about binary, decimal, and hexadecimal, so you'd be aware of this, how to read binary data. And here's some file types. So files all are just a series of bytes. This is actually arguably a mistake. but it is the way computers, so there's no difference between our executable program, a text document, an image, and when you do the exploit development class, which you're not doing this semester, you exploit this. You can put in a password and then interpret it as executable code and execute it. That shouldn't be possible, and there are proposals to fix this. It would probably make more sense to just have 12 bits in a byte and have the remaining 4 bits after 8 indicate what type of data is stored here, so that executable data is just fundamentally different than, say, text data. That would be a whole lot more secure, but that's not what we're doing. We're using a system that dates from a really long time ago when they just had to squeeze the most value out of every bit. And so there are certain patterns, headers and footers. So JPEGs start with FFD8 and they end with FFD9. PowerPoint PDFs start with %PDF. Zip files start with PK, the initials of the guy that wrote it, Phil Katz, and so on. There are just binary headers and footers that determine the file type. And your forensic tools like Autopsy will automatically recognize this, and this is what they do to recover deleted files. You don't have the file name, you don't have the extension, you don't know what it is, you just find a file and you look to see if you can find what looks like the start of a file because it has a known header, and then you try to find the end of it one way or another. Some files have a nice footer, some don't, and then it tries to put it together and reconstruct it, and it's not very good at it. For example, if your image, store an image and it's fragmented, so there's extra junk in between, most forensic tools will leave that junk in there, so you'll get a strange distorted image with part of an image and then some junk and then part of more the image. There are some tools that actually do a better job of reconstructing it, but they aren't the common ones in use because most of the time it's good enough to just assume that the whole file will consist of contiguous blocks. All right, now when you boot up a Windows machine, it has to load the kernel into the kernel is the part of the operating system that must always be in RAM while the machine is running. Well, let me check for questions. Just hello. Okay, good. All right. When you power it on, it goes to the ROM, read-only memory, that remembers when the power's off. Then it goes to the BIOS, which probes to see what devices you have. Do you have a hard drive? Do you have a keyboard? Do you have a mouse? What have you got? And only if it finds a sufficient number of devices will it boot up. But I will say, failure, there's no keyboard. I give up. I'm not going to boot unless I have a storage device and a keyboard and a monitor. Once it finds that, then it bootstraps, starting the code, starting the operating system, finding an operating system on a storage device, and booting from that in a series of stages. Now, in the old days, there was something called BIOS. In the modern days, it's UEFI, is the modern replacement for the BIOS, which has more features, but does the same job. All right, the master boot record is the first sector on the hard disk. And this stores information about the partitions, unless you're using the more modern GPT system, GUID partition table. But Windows machines are often still using this. So you have a master partition table, which lists the sections of the disk that have typically what's been assigned drive letters in Windows, like C, D, and E. And all right, it's got a master boot code that never varies, and a disk signature, and an end of sector marker. And we'll go into this in much more detail in the malware analysis course. We're going to totally be examining these. All right, so Windows supports a whole series of FAT file systems, file allocation tables, which are the old system, only used for movable devices like floppies these days and thumb drives. And NTFS is the more modern system, developed in 1993 for Windows NT, and it had minor version upgrades, but they never done it. Microsoft has many times promised that they're going to make a new file system, but they just gave up and didn't do it every time. They just stuck with NTFS. So FAT was for floppies, FAT16 was for MS-DOS and Windows 95. It can only go up to 2 gigabytes, so it's really not much use anymore. FAT32 can get somewhat bigger, and FAT64, exFAT, in principle can also be used by Mac OS and might be compatible, although I've seen some problems with it. All the FAT systems lack journaling, which is a really serious problem, which means if you're running something like Windows 98 and it crashes with like the blue screen of death, and it's in the middle of a write operation, like saving a file, it will just give up. And when it boots up next time, it will say, lost clusters found on disk. It will spend 15 minutes hunting for them. It will say, there's clusters on the disk that I don't know what they are. And so it's going to sweep them into files and call it file 000, file 001, file 002 in the root of C, and that will take 15 or 20 minutes. That's very annoying. The Linux had this problem solved much earlier, and Windows built it into NTFS journaling, where every time it does anything, it records what it's doing in a journal. Now, I learned about this when I was working as a database analyst at a financial company. I was handling hundreds of millions of dollars, and it was a madhouse. I would be working on a case, and then the phone would ring with a client with an emergency, and I'd have to drop it. Then the boss would come in with another emergency. Then I'd go off and do that for a while. Then I would come back, and now I've only got 2 hours to finish it, and I have to remember to pick up where I left off. So I learned to do this. I would keep a journal of everything I'm doing. Okay, now I'm restructuring the database. Now I'm moving these fields over here. Now I'm adding these columns. Now, poof, I have to go do something else. When I come back, I can remember how to pick up where I left off. And that's what the modern computers do. So if some process is interrupted, they can just pick up where they left off smoothly and not have this problem of creating corruption on the disk. So NTFS has other features like file compression, a way to make files a little bit smaller, not really worth much. Unicode, though, so it supports most international languages and is 16 bits for character instead of 8. Access control lists are the main thing you want. So you have a list for every file. Administrators can have full control. Users only have read permission, and so on. You have enough room to store all this permission information about every file and every folder, which you cannot do in FAT. FAT has no permissions. Physical access to the drive means you can read and write anything. And that was, back in the early days. And so it's got other things stored, like sequence numbers, keep track of changes that are made. And it's got alternative data streams, which is the thing you don't come across very often, a Microsoft feature intended for compatibility with Apple. For music is where it started, where you would have the audible music, and then you would also want to have like the album art and the notes. So many streams of data would come from one file name. That's what alternate data streams are. They're not that important, but there was a time, maybe 10 years ago, when people would hide malware in the ADS, and the existing malware scanning tools didn't look there. Now they've wised up. All right. So here's a summary of these types of systems, which is kind of of historical interest. You don't see much in the way of FAT anymore, except thumb drives. Pretty much everything is NTFS. Right. Yes, Android might. Yeah, that's a good point. Yeah. Right. Anyway, so master file table is, it has all the metadata. It has all the file names, all the permissions, and all the timestamps of all importance to us. So it had an entry for each file and folder that's 1,024 bytes. That's right, it has enough room to store a whole big table of all kinds of permissions and stuff. It's got timestamps. You can modify them with a variety of tools. So you can't necessarily trust timestamps. That's a fundamental problem with Windows. The logs could be altered. Everything on the disk could in principle be altered. So this is a thing to be aware of when you go to court. The fact that you find evidence on a Windows machine doesn't mean it's 100% reliable. All right, and here's the kind of thing you'll see there, entries in the master file table. The prefetch files are extremely handy. Prefetch, every time you open a program on a Windows machine, it stores a shortcut in the prefetch file folder, or a binary entry. It's not exactly a shortcut. And the point is, next time you boot up the machine, typically you boot up your machine, you type in a password, and then you do something that doesn't demand much, like you open a web browser and read things. So the machine is just sitting there doing nothing. So while it's not serving you, it will get ready, anticipating your needs. It will go to the prefetch folder and say, well, the last time they used the machine, they opened this program, so I'll just get it ready in RAM. I'll get this one ready in RAM. It keeps track of what you've done, so it'll respond more quickly if you do the same thing you did before. It's extremely handy for forensic examiners because the last 128 programs that were launched are stored there with when they were launched and what user launched them. It's very handy. That's why I say, there's tons of artifacts created on Windows machines recording everything you do, even though it's not intentionally auditing and spying on you. Just the natural operation of the operating system does leave tons of records of everything you do, and therefore you're in big trouble if you want to do anything on the computer and then lie about it. So they're stored in the prefetch folder, and you'll just find a series of files here with a PF file extension. You have to use a special tool to open and read them, although Autopsy will do it, just like pretty much everything. Superfetch files were some kind of way to enhance memory that really didn't accomplish much. Shellbags, however, are quite useful. If you open a window, like I can do it on my Mac, if I open, say, a Finder window, and I take this and I open, say, this program here, I have 121, and then I choose the view to be like, I don't know, their icons, there. So if I close this window, when I open it, will remember where it is and what view it was in. That's what the shellbags do. Now this is a Mac, but Windows does it. It has some equivalent thing. So it's remembering every window you may opened and where it was and how big it is and the parameters of it. So again, it shows what you've been doing. Just so next time you open that window, it'll put it right where you did it last time in the same view. And Shim Cache has items, executed binaries that have been viewed but not executed. It's also used, I think, for compatibility with for programs that are written for older versions of Windows. All right. And then there's the registry. But before we do that, let's try a Kahoot. I think my first Kahoot goes up to this point. So that's going to be my favorites. And mod 2B. All right. All right. So go to kahoot.it and put in that number. If you want to play, there's 3 points of extra credit you can earn if you score the highest in the Kahoots, the top 3. And if you use a fake name like those, you'll have to tell me your real name if you want your points. I'll wait a few more seconds. Oh, people still coming. Okay. Yeah, 24 people in Twitch, so might be more coming. Well, I guess not. All right, let's go ahead. Oh, okay. Well, wait a few more seconds. Oh, okay. Well. All right. All right. Which one of these is 512 bytes? A sector, not a cluster. It's the smallest unit of data you can read or write from a hard drive. Right. What's the first sector on a hard disk? That's the master boot record. All right, so what file system does Windows use? NTFS, all modern versions of Windows use it. All right, so what artifact records recently executed applications? prefetch files. All right. All right, well, I want to take a 10-minute break before we continue. I'm going to stop this recording.